Good morning. So we're going to see about horizontal and slant asymptotes. Let's see. Of rational functions. Let's say we have a rational function and this is a polynomial divided by another polynomial. And the first polynomial, the numerator, has degree m and leading coefficient a. Notice that it's written in standard form. We won't care what happens next. It's written in standard form. And the denominator has degree n and leading coefficient b. Yesterday we didn't have it in this form. We were finding vertical asymptotes, we were finding holes and x-intercepts. But now to find horizontal and slant asymptotes, we needed it as a polynomial in standard form divided by another one in standard form. Well, and then you just simply look at the degrees. If m is less than n, in other words, if the degree in the denominator is greater than the degree in the numerator, then the line y equals 0, yes, this is the x-axis, is the horizontal asymptote. Well, I'll make a drawing in a few minutes. If the degrees are the same, if m equals n, then the line y equals a over b, we take the leading coefficients and divide them, is the horizontal asymptote. And if the degree in the numerator is greater than the degree in the denominator, then there is no horizontal asymptote. Okay? However, if this is the case, and the degree in the numerator is just one more than the degree in the denominator, there is a slant asymptote. This is a diagonal asymptote. So we'll see how this looks. Horizontal asymptotes and slant asymptotes, unlike vertical asymptotes, they can be crossed. A graph can cross a horizontal asymptote as long as it doesn't do it at the ends. It can cross it in the middle of the graph, but not at the ends. For example, let's say the simple graph y equals 1 over x. Well, the degree here is 0 and the degree in the denominator is 1. So the line y equals 0 is the horizontal asymptote. This looks, in the graph, looks quite like this. It does have a vertical asymptote. We're not dealing with that anymore. And over here. As we go farther to the right or farther to the left, the graph gets closer and closer to the x-axis, which is the line y equals 0. Okay. And that, a horizontal asymptote, let's say this other graph has horizontal asymptote, let's say this one, y equals 2. So it really doesn't matter what happens in the middle. Towards the end, the graph will get closer and closer to this line. For example, it could happen something maybe like this. See, it doesn't matter that it actually crossed it. Maybe it had a vertical asymptote somewhere over here. And then it went like this. Okay? Now, okay, so let's say this other equation. Let's say we have y equals 3x plus 5 times 2x minus 6 over 4x squared plus x minus 8. Okay, does it have a horizontal or a slant asymptote? Well, because it's not written in standard form, we would have to rewrite it in standard form. Okay, we multiply this out, and we get 6x squared. This is minus 18x squared minus 18x plus 10x minus 30 over 4x squared plus x minus 8. Yes, I know we can put these two together. But really, to find the horizontal asymptote, we don't need it. All we need is the leading terms. The degree is the same, 2 and 2, so the horizontal asymptote is 6/4. Y equals 3/2, 1.5. Okay, so how do we find the slant asymptote, if there is one? Let's put an example. Notice that the degree in the numerator has to be 1 more than the degree in the denominator. Okay, so let's say we have y equals 4x cubed plus 3x squared minus 7x plus 8 over x squared minus 2x plus 5. Okay, the degree 3 is 1 more than the degree 2, so it has a slant asymptote. In order to find it, we need to divide. So we're going to use long division because this is not linear. We can't use synthetic. So I'll put x squared minus 2x plus 5 divided into 4x cubed plus 3x squared minus 7x plus 8. Okay, so x times what is 4x cubed? Well, that is 4x. So multiply, I'll write it in green, that's 4x cubed. 4x times negative 2x is negative 8x squared. 4x times 5 is 20x. Now we subtract, which remember, we just change the signs and add. Cancels. This is 11x squared. This is minus 27x plus 8. So what times x squared is 11x squared? Okay, that is 11. So plus 11, I'll multiply 11 times x squared is 11x squared. 11 times negative 2x is negative 22x. 11 times 5 is 55. And then change the signs and add. That is subtracting. Change the signs and add. Cancels. This is negative 5x and negative 47, which is our remainder, which we'll write over here. Plus negative 5x minus 47 over x squared minus 2x plus 5. Alright, after doing that division, the slant asymptote is simply the quotient without the remainder part, the whole part of the quotient, this. Now it's a line. The slant asymptote is y equals 4x plus 11. And that's it.